Hello, my name is Meredith Moore. I'm going to cover how to identify outliers within SPSS. An outlier is data which does not fall within normal range of a random sample. The researcher must calculate the outliers either by using the outlier labeling rule formula or using box plots. After identifying the outliers, the researcher must identify if the outliers should be removed or used within the research. Researchers need to identify outliers in their data because outliers can skew their data, which can pull the mean and misrepresent the data. The p-value will not reflect accurately. The outliers can misrepresent the sample population according to the research question or hypothesis. First, the educator will need to have his or her data within a Microsoft Excel sheet and saved on his or her smart device or flash drive. Here I have posted 3 results from a sleep study. Second, the educator can now access his or her SPSS account. Click New Dataset, click OK, click File, click Open, click Data. Locate the Microsoft Excel document on your smart device or flash drive. Click Open, click OK, click Analyze, click Descriptive Statistics, click Explore. Place all 3 variables in the dependent list. Click on Statistics, uncheck Descriptives, click Outliers and Percentiles, click Continue. Click Plots. Under Descriptive, uncheck Stem and Leaf. Click Histogram. Click Continue. Click OK. The SPSS Viewer page will appear. The page is displaying the case processing summary, the percentiles, extreme values, the histograms for each variable, and the box plots for each variable. Now let's view the percentiles. We are going to use the 25th and 75th percentile of each variable to calculate the outlier labeling rule formula. Here are the equations. To determine the upper outliers, the equation is as followed. Third quartile plus parentheses 2.2 parentheses third quartile minus first quartile parentheses parentheses. To determine the lower outliers, the equation is as followed. First quartile minus parentheses 2.2 parentheses third quartile minus first quartile parentheses parentheses. The third quartile is the 75th percentile and the first quartile is the 25th percentile. We are going to use 2.2 as the multiplier based upon the 1986 article, Performance of Some Resistant Rules for Outlier Labeling in the Journal of American Statistical Association. The 2.2 decision is based on regular sample sizes and normal distribution. For the first variable, average sleep, the equations are as followed. The third quartile, or the 75th percentile, is 8.60. The first quartile, or the 25th percentile, is 7.4150. Once we plug in the numbers and complete the math, the upper outlier is 11.207. The lower outlier is 4.808. Let's look at the extreme values for average sleep. Based upon the equation, the upper value is 11.207 and the lower value is 4.808. We do not have lower and upper outliers. For the second variable, GPA, the equations are as followed. The third quartile, or the 75th percentile, is 3.5. The first quartile, or the 25th percentile, is 3.0. Once the numbers are plugged in and the math is completed, the upper outlier is 4.6. The lower outlier is 1.9. Let's look at the extreme values for GPA. Based upon the equation, the upper value is 4.6 and the lower value is 1.9. We do not have lower and upper outliers. For the third variable depression, I'm going to use a box plot to identify the outliers. Here's the depression box plot. The bold line is the median. The bottom of the box is the 25th percentile. The top of the box is the 75th percentile. These lines are referred to as the whiskers. These are the extreme points. The data above and below the whiskers are outliers identified by SPSS. The outliers are identified by circles and stars. The numbers correspond to the case number in the SPSS data editor. For instance, 64 equals 28 in the chart. The star outliers are extreme outliers in the data. SPSS uses 1.5 to calculate outliers. Therefore, the outliers for the variable depression should be 195, 64, and 118 in the box plot. That concludes my lesson on identifying outliers.